Okay, here's the answer solutions to the test review. And number one, it's a true or, well, it says state whether each sentence is true or false. And then if it's false, we're going to replace the underlined word with a word that's going to make it a true sentence. So number one says, if angle 1 is congruent to angle 5. Well, here's 1 and here's 5. Then lines P and Q are parallel lines. Well, when corresponding angles, these are corresponding because it's top left, when corresponding angles are congruent, then the two lines that form them, and the transversal, but the two lines that form them, P and Q, are parallel. So this is a true statement. Number 5 says that line T, let me get rid of all this, line T is the transversal for P and Q. Well, remember, a transversal is a line that intersects two or more lines. So T does just that. It intersects line P and line Q. So this is true as well. Okay, number 8 says to classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, or consecutive interior. So angle 1 and 5, 1 and 5. Well, once again, just like the last problem, or problem number 1, you have bottom left corner, they're in corresponding positions. So these are corresponding angles. Number 8 says that measure of angle 8 is 96 degrees. It should be 96 degrees. But 96 degrees, and the measure of angle 12 is 42 degrees. We're going to find the measure of each angle and then tell which postular theorem we used. Now, this is going to be the same, 96 and 42 are going to be the same for all of 8 through 10. So we have to find angle relationships in order to figure out what the missing measures are. So we're looking for angle 9. Well, angle 9 doesn't have an angle relationship with angle 12 because this line and this line are not parallel. I can see that this line and this line are parallel because they marked them parallel, but because these two lines are not parallel, then 9 and 12 are not going to have any sort of relationship. So I look at 9 and 8. Angle 9 and 8 do have an angle relationship. They're called consecutive interior. Remember, your reason for these are the name of the angle pair and to find the measure of angle 9, what are consecutive interior angles? Well, consecutive interior angles are supplementary, so they should have a sum of 180 degrees. So if angle 8 is 96 and there's 180 degrees between them, I subtract 96 from 180 and I'm going to get 84 degrees. Okay, number 11, determine the slope. Slope formula is to take rise over run or y's over x's, subtract your y's over the difference of your x's. And remember, this first value is my x value, second value is my y value. So I'm going to do y minus y, so 1 minus 6 over x minus x, which is 8 minus 8. 1 minus 6 is negative 5, and 8 minus 8 is 0. So look what happens, whoops, look what happens when I take 5, or sorry, I guess a negative 5, and divide it by 0. Hold on, let's try that again. Negative 5 divided by 0. Oh, look what happens. You cannot divide by 0. In your calculator, you're probably going to get a big error message, or it'll say like no domain, or I can't remember what your TI 83s do, but the bottom line is when you don't get a number as your answer, the slope is called undefined. Remember, that's your vertical line going straight up and down. That's when you divide by 0. Okay, number 14, we are using the picture at the right and asked, is it possible to prove two lines parallel given the following information? So what we're looking for here is we're looking for corresponding angles congruent, alternate interior angles congruent, consecutive interior angles supplementary, and alternate exterior angles congruent. If we have any of those relationships, then we can prove parallel lines. Well, this one says that angle 1 is congruent to angle 7. Well, just look at angle 1 and angle 7. You have this. Is it even possible that there are parallel lines that exist between those two lines? No, these are intersecting lines. They're not parallel. Vertical angles do not prove parallel lines. That's your reason why we have no parallel lines, because vertical angles do not prove parallel lines. Remember, we learned about vertical angles like chapter 1 and 2. Chapter 1 and 2 had nothing to do with parallel lines. The relationships that do have something to do with parallel lines are corresponding, consecutive interior, alternate interior, and alternate exterior. So if you're given a relationship from chapter 1 and 2, so if you were given a linear pair, they would not prove that lines are parallel. Alright, number 18 says that if line L is parallel to M, oh, there should be an L here and an M here. And they even marked parallel, so we're good. We're going to find the missing variable and the measure of IFG. So if two lines are parallel, this line and this line are parallel, and we have alternate interior angles form that Z. Remember, what lies inside the cusps of your Z are alternate interior angles. They're inside these two lines on alternate sides of the transversal, now that I've covered everything up. And alternate interior angles are congruent. So in geometry, congruent means equal. So x plus 20 is equal to 3x minus 12. I'm just going to subtract 20 from both sides. So I would get a negative 32, bring down my 3x equals x. Subtract 3x from both sides. So I get a negative 2x equals a negative 32. Divide by negative 2 on both sides. And then I get negative 32 divided by 2 is 16. So x is a positive 16 because I did negative divided by a negative. And then that's my x value, so you're going to put that here. Then the measure of IFG, well, I always check my x value anyway, so I'm going to find IFG and I'm going to find JIF just to make sure I did it right. So 3 times 16 minus 12 is going to give me, 3 times 16 minus 12 is going to give me 36. And 16 plus 20 is going to give me 36. So by plugging my x back in, I know I did it right because this does equal this. And my answer for IFG is 36 degrees. Okay, number 22, it says, let's read the instructions. Find the value of x so that L is parallel to M. So if we want to figure out that L is parallel to M, we have to prove that these two are supplementary. And why are they supplementary? Well, consecutive interior angle converse says that if you have consecutive interior angles that are supplementary, then the lines that form them are parallel. So if these equal 180, then we can prove that L is parallel to M. So I'm going to set 4x plus 35 plus x minus 15 equal to 180 degrees. First step is to combine my like terms. 4x and x is 5x. 35 and negative 15 gives me a positive 20. That equals 180. Subtract 20 from both sides. I get 5x equals 160. I'm going to divide by 5 on both sides. So I get x equals 32. I'm just going to check my answer to make sure I did it right. 4 times 32 plus 35 gives me 163. And 32 minus 15 gives me 17. So if I did this right, then their sum should equal 180. 163 plus 17 gives me 180. So I did it right. All right, number 23. It says transversal T intersects K and J as shown, and then it says which of the following relationships will make J parallel to K. So in this question, we're trying to figure out when do we have corresponding angles congruent, when do we have consecutive interior angles supplementary, when do we have alternate interior angles congruent, when do we have alternate exterior angles congruent. So if we can find any one of those four relationships in this set of answer choices, then we have proven lines parallel. Well, the first one says, well, 2 is congruent to 3. 2 is congruent to 3. Okay, yes, 2 is congruent to 3, but that's because they're vertical angles. And vertical angles have nothing to do with parallel lines. So vertical angles are not going to prove lines are parallel. 1 is congruent to 3. Okay, well, first of all, 1 and 3 are not supposed to be congruent. 1 and 3 are a linear pair. And a linear pair is supposed to equal 180. So if this had said 1 plus 3 equals 180, that would be a true statement. But a linear pair has nothing to do with parallel lines. Look, here's your linear pair. Where are the parallel lines? Parallel lines look like this. I don't see this in linear pair. So that's not going to prove my lines are parallel. The next one says that 4 and 5 are supplementary. Well, here's 4 and 5, and they're supplementary. Great, you're right, they are supplementary because they're a linear pair. But once again, 4 and 5, linear pair. Where's my parallel lines? I don't see any. Parallel lines have nothing to do with linear pairs. Linear pairs are always supplementary whether the lines are parallel or not, because there are no parallel lines. And finally it says 3 and 4 are supplementary. Well, here we go. Now we have what looks like parallel lines, K and J. And because 3 and 4 add up to 180, or they're supplementary, then that's going to prove that J is parallel to K, because when consecutive interior angles are supplementary, then the lines that form them are parallel. Number 27, length of a line segment. Well, that is last chapter, but it's never going away. My distance formula, x minus x squared plus y minus y squared. My x values are my first values, 3 and 4. 3 minus 4 squared plus negative 2 minus negative 2 squared. 3 minus 4 is a negative 1. I'm going to square it. Plus negative 2 plus 2 is 0 squared. Negative 1 squared is like saying negative 1 times negative 1. And that equals a positive 1. And 0 squared is saying 0 times 0, which is 0. So that's 0. So the square root of 1 is 1. And that's the length. Alright, number 30. It says use the graph on the right to give the slope of the following lines. Line CD. Here's line CD. Remember, slope is your y's over your x's. So first I figure out how does point C turn into point D. Well, first of all, from left to right, is it going in the positive direction or a negative direction? Well, from left to right, it's going up. So this is going to have a positive slope. And from C to D, how do I get from C to D? Well, I can go y 1, 2 over x 1, 2, which gives me a positive 1. Or I could go from D to C, y 1, 2, x 1, 2. Either way, I get 2 over 2, which is a slope of 1. Number 33, which equations of a line is perpendicular? Well, remember, perpendicular, we take our original slope, let's just say it was 1/3, and we make it the opposite sign, negative, and we flip. So negative 3 over 1 would be perpendicular to 1/3. Well, in this equation, the slope, y equals mx plus b, where m is our slope, the slope is 6, and as a fraction that is 6 over 1. So perpendicular would be flip the fraction, 1 over 6, and make the sign opposite. So opposite of a positive is a negative. So we're looking, as long as all of these are solved for y equals mx plus b form, we're looking for the negative 1/6 slope. That's the one that's going to be perpendicular to the given equation. So the only one that has a negative 1/6, not this one, not this one, this is a negative 6, this is your negative 1/6. The only one that has an opposite reciprocal is C. Alright, that should pretty much get you ready for your test. Good luck!